Okay, so 6.8 is looking at indefinite integrals, which means we are no longer given any bounds. So this is where the plus c is going to become the most important here. So in the first part, it says find the derivative of each function. So go ahead and take 20 to 30 seconds and find the derivative of those three functions.
The derivative or just...
The derivative, yes. Not the antiderivative, the derivative. That's why I said 20, 30 seconds. It should be super quick. Okay, so as you're looking at those derivatives, what do you notice? They're all the same, okay? So the derivative of this one is 2x, derivative of this one is 2x, and the derivative of this one is 2x. So what's the difference in the original functions? The c value, the constant. So one is +1, other is -5, and the other is 1,000. So if you were given the derivative, so you were given 2x, and I was asking you to take the antiderivative, would it be as easy to figure out what constant is the c value? No. So that's why we write plus c, because we don't know what the c value is unless given other information like number 7 on the last notes. So what this gives us or makes us do is find the general solution. So the general solution means we find whatever the antiderivative is and we add c. Okay. If we're given more information, we are able to find the particular solution. And in that particular solution, they were able to find an exact c value at c equals 1. Okay. When we are without a boundary, this is an indefinite integral. Okay, without a boundary is an indefinite integral. Okay. So when we're working with indefinite integrals, what we're doing is finding an antiderivative and calling that the general solution. So we have some more unique functions here. We have exponential. So when you're thinking back to when we learned derivatives, we know that the derivative of e to the x is what? E to the x. So what do you think the integral of e to the x is? E to the x, and then we write plus c. Okay. For the next one, the integral of a to the x dx is going to be 1 over the natural log of a times a to the x plus c. Because recall that the derivative of a to the x is a to the x natural log of a. Okay, so opposites. So knowing these, bless you, we're able to find the general solution of the integral 7 to the x power dx, and what would that be? Perfect. 1 over the natural log of 7, okay, times 7 to the x power plus c. In this case, we're just replacing a in that formula for the integral of a to the x with 7. Okay. Versus number 2, notice in number 2 that it wants us to find the particular solution. So since it wants us to find that, they gave us more information. So they said f of 0 is equal to 4. Okay. So first, we would find the antiderivative. Okay, so starting with just e to the x, what would be the antiderivative? E to the x. And then looking at negative 2x squared, the antiderivative would be, perfect, negative 2x cubed divided by 3. Okay, and then plus c. Okay, from here, we're using that extra information of f of 0 is equal to 4. So we have 4 is equal to e to the 0 power minus 2 times 0 cubed over 3 plus c. Anything to the 0 power is 1. So technically we have 1 minus 0, or just 1, plus c. So that means c is equal to 3. Right? Because this is 1. This is away, it's 0. So it's 1 plus c. So if we get rid of the 1, we subtract the 1 to the other side, we get c is equal to 3. Okay? And once you find your c value, this is going to be the most important step. Don't just leave it like this. Don't just say, okay, I found that c is equal to 3. You got to plug it back into that original function. Okay? So we have f of x is equal to e to the x minus 2/3 x cubed plus 3. That entire thing is our answer. Because it wants the particular solution, not just the c value. Okay, any questions on exponential? Okay, let's look at logarithm. So if we're looking at this integral, this is the integral of 1 over x dx. Okay, what would we have to take the derivative of in order to get 1 over x? The natural log, which means the integral of 1 over x dx is the natural log of x plus c. Just make sure we put that x value in the absolute value, so we're only plugging in a positive x into the natural log. Okay. So looking at number 3, the first thing I would do is, since we're dealing with the logarithm here, I know I need to have this in some integral where it has 1 over x. Okay. So technically I could rewrite this as the integral of 1 minus 5 times 1 over x dx. So I can visibly see the 1 over x here. And I know when I take that integral, it's going to turn into the natural log of x. So this is going to give me what as my answer? But what about, we're starting right here at the first part. What would be the antiderivative of 1? X, right? Because technically this is 1 times x to the 0 power. Let me not write it like that. I don't want it to look like an exponent. Okay. So this is x, and then we have minus 5 times natural log of x plus c. Okay, so we broke it apart. Okay, the integral of 1 is x. The integral of negative 5 times 1 over x is negative 5 natural log of x plus c. Okay, if this helps, you could break this apart further. You could say that this is the same as the integral of 1 dx minus 5 integral of 1 over x dx. Okay, going back to the properties of the integrals that we did a couple notes ago. Okay, that would be another way to get the same answer. Okay, divide that up if it's easier. Okay, on number 4, it wants us to find the particular solution, which means they had to give us more information, which they did. Okay. I would first take this and I would rewrite the derivative to be 2 times 1 over x plus 6 times x to the negative 2 power. Okay, bringing that x squared up out of the denominator and seeing that 2 over x is the same as saying 2 times 1 over x. Okay. Okay. Taking the antiderivative, what would it be in that first term here, that 2 times 1 over x? Good, 2 natural log of x. And then the next term, what would be the antiderivative here? Bless you. plus 6 x to the negative 1 over negative 1. Okay? Well, that's the same as just saying 2 natural log of x minus 6 over x. Let me make sure I simplified. Yep. Okay. So then from here, of course, what am I missing at the end? Plus c. It wants us to find that c value by saying that this thing is equal to negative 7 if you plug in 1 for x. So 2 natural log of 1 minus 6 over 1 plus c. Well, what's the natural log of 1? 0. So that whole thing's gone. Okay, natural log of 1 is 0. So I have negative 7 is equal to negative 6 plus c, which means c is equal to negative 1. So that means I have my answer, f of x is equal to 2 natural log of x minus 6 over x minus 1. That is my particular solution. Any questions on 4? Okay. Okay, now looking at more trig integrals. Okay, we already did the first two. We know the integral of cosine is sine, so this is sine x plus c. The integral of sine is negative cosine plus c. And then the rest of these, if you're able to think backwards, okay, if you're able to think, okay, what did I have to take the derivative of to get what is inside these integrals, then you won't really have to memorize anything. This is nothing new, okay? So I'm just going to go ahead and fill out this table. And then we're going to do the same thing. So number 5 and number 6, we're finding the general and then the particular solution. So on number 5, we could rewrite this as 3 integral secant squared x dx. Okay, if it helps us to remove those extra constants, coefficients, at the front, then we're going to do that. And then looking at our table, we know the integral of secant squared x is tangent x plus c. So this is equal to 3 tangent x plus c. Number 6 gives us the derivative 1 minus sine x, and it wants us to find the particular solution, and then it gives us f of pi is equal to pi minus 2. Okay, so the first thing I'm going to do is I'm going to rewrite this. I guess I don't have to. No, okay. Let's just find the antiderivative of 1 minus sine x. So what would be the antiderivative of 1? X. What's the antiderivative of negative sine x? Plus cosine x, and then we can't forget the plus c. Okay? We know that this whole thing is equal to pi minus 2 if I plug in pi. So pi minus 2 is equal to pi plus cosine pi plus c. Okay. What is cosine of pi? I'm sorry, I'm just looking at the key. The key's wrong. Okay, so pi minus 2 is equal to pi, and then cosine of pi, you guys are saying -1, so plus -1 plus c. Okay, then I just solve for c. So the pi's are going to cancel out when I subtract them over. Okay, and then if I add 1 to the other side, I get c is equal to -1. Okay, so I am left with, well, let's put it in terms. F of x is equal to x plus cosine x minus 1. And that is my particular solution. Okay. Then I have the inverse trig derivative. So notice here it's just the derivatives. Okay, these are part of our previous notes. And if we can recall the inverse trig derivatives and we recognize these in our integrals, then we are able to use this as a shortcut to work backwards. Okay, so again, these are things that we already learned in this box down here. It's the inverse trig derivatives. So what it's saying is if you recognize these as a derivative of an inverse trig function, then you should be able to think backwards and say, okay, if I have the integral of this, then I know it's going to be equal to one of those inverse trig functions. So for example, number 7 says the integral of 1 over the square root of 1 minus x squared dx. Well, that matches right here with the derivative of the inverse of sine. So that means this integral is equal to the inverse of sine plus c. Okay. Same with number 8. Number 8 looks like what? Good. The inverse of secant plus c. So these would just be things that if you haven't memorized them yet, when we did the unit on derivatives, I would memorize them now. And then the last thing, which we kind of already mentioned before, is that we can separate or combine expressions in our integrals. So for example, we have on number 9 the integral of 3x squared plus x minus 2 over x dx. Well, that's the same as separating each of these into its own integral. So this is 3x squared over x dx plus x over x dx plus -2 over x dx. Okay. If I was to simplify this further, this is the integral of 3x dx plus the integral of 1 dx. And I can even bring out the -2, so -2 integral of 1 over x dx. Okay. So if I solve these individually and put them all together with that plus c at the end, that's the same as solving that original integral. So this is 3x squared over 2 plus x minus 2 natural log of x plus c. Okay, it's a lot easier if we can separate it versus not separating it and trying to find the integral of this larger rational function. Okay. Same with number 10. Just like we can separate them, we can also combine them. And I know the bell's about to ring, but I'm going to keep on talking because I'm recording. So just keep that in mind. Okay, so if I combine them, that's the same as me distributing that 3x inside the parentheses. So this would be the integral of 3x times the square root of x, okay, plus 3x cubed, because 3x times x squared, and that whole thing as times dx. So I could say this is 3. Okay, bye guys. I'll see you tomorrow. I'm going to keep talking, though. I'm going to finish this one out. 3 of x to the 1 and x to the 1/2, which would be x to the 3/2, okay, plus 3x cubed dx. And if I take the integral, I would have 3x to the 5/2 divided by 5/2 plus 3x to the 4th divided by 4 plus c. And then I can simplify that to be 2/5 3x to the 5 halves plus 3/4 x to the 4th plus c. And that would be my answer.